Okay. Okay, so this is the Epanet interface. Just like in every window-based program, the interface have different task bars and toolbars. This is your window menu. We all know it. It's everywhere. The second one is your standard toolbar, and then these are your toolbars. So I can click and drag it this way, just like you have in AutoCAD. This is my toolbars. This is where I'll be working on. Then this place is my drawing area, or called the network bar. Then there's a small window somewhere here. It is called a browser. The browser window has other two sub windows or two tabs. This is the data tab, and this is the map tab. You use the map browser to view your results, while you use the data browser to impute your value, your variables. For instance, if you go to this flyout, there's a small flyout here. If you click on it, it will tell you all the components of a centralized water supply system. You have your junction, you have your reservoirs, you have your tanks, you have your pipes, you have your pumps, you have your valves, and so on and so forth. And when it's time for results, if you want to view your results, you simply go to map. When you get to map view, it will not tell you what you want to view. What parameter, what part of your parameter do you want to view? Do you want to view the elevation? Do you want to view the base demand? Remember what we always taught last time. Do you want to view the quality, the water quality? Do you want to view the real demand? There's a base demand and there's a real demand, remember? And then do you want to view the head at that point? Or do you want to view the pressure at that point? Or do you want to view the quality at that point? And these are the parameters you view on your node. On your node. Then if you want to view parameters on your link, remember your link is your pipe. Your node is like your junction. The node, I taught us yesterday about nodes. Then a link, you can view the length of the pipe, you can view the diameter of the pipe, you can view the roughness of the pipe, you can view the flow, you can view the velocity, and so on and so forth. So, but this is after you must have done your model. We now view it here. Then if you do simulation, this one will come up. This simulation toolbar will come up. Not on now because we've not simulated anything. It will bring in timer for you that you can view your result at any point in time. Let's say you want to simulate for 72 hours and you want to see the result after 24 hours. You simply go here and click, and then you take it to 24 hours. Then you can view the instantaneous results at that point. So now, let me introduce us. Now, for any tool that you don't know what it's used for, just hover your mouse around it. Hover your mouse around any toolbar, and it will tell you what that toolbar is used for. For instance, if you come here now, you hover around it to tell you this is a label. This is for valve. This is for pump. Please follow me, join me. This is for pipe, if you want to add pipe. This is for to add tank. This is for reservoir. This is for junction. This is for full extent. This is for zoom in, zoom out, and so on and so forth. Then for the standard toolbars, this is for new. This is for open, to open a saved project. Then this is for to save your project. This is to print your project. This is to copy your project. This is to delete. This is to find. This is to run. Okay. Now, let me demonstrate something before we start. Okay, let me demonstrate something before we start. Let's assume I want to draw, or let's just start with the exercise. So then for the menu, if you click on any of the menu, you see the drop-down arrow. It will tell you the other constituent of that, of the menu, what comprises the menu. If you click on this one, project, it will tell you the constituent of that project. So any of them that you click will give you the constituent of any of them. This is file. It will show everything. So for the purpose of this class, we're going to do one exercise called Epanet exercise 1. So I want you to open it. I ask us to print it. If you print it, it will be easier, it will be more flexible for you. But if you forgot to print it or you don't have it printed, kindly open the soft copy from your folder. And this is how you're going to locate it. If you go to your training folder, this is your training folder. Okay, everybody have it. It's in the cloud. You go to Epanet files and data for Epanet. If you open it, you now go to Epanet exercise 1. Epanet exercise 1. So you can double click it and then you open it. Please, if you have opened it, just say yes on the chat bar so we can start. If you have opened it, go to the chat bar, say yes. Oh, good. Gimba say yes. Yes, me too. I say yes. I'm good to go. Let me just have 2 more yes. If you have opened your software, yes, I have a hard copy. Okay, Chimezi has a hard copy. Better, beautiful. Then another thing is that if you have said, or if you have opened your software, also say yes. Yes. Yes, I have the software. I have the software open. Okay, I have the software. Yes, I have the software open. If you have installed the software, you can't find it, just type Epanet on your search. It will bring up the software. Then you can now pin it to either your taskbar or to your menu bar. Now, I want everyone to follow in this exercise. It's not going to be difficult, I promise you. Don't say you know it later, I'll practice later. No, just follow me as I'm doing it. You're going to enjoy it, you're going to see it. It's very simple. It's an open source software from the EPA, Environmental Protection Agency of the United States. It's very simple to work, to use, and they have been modifying it. They have been bringing new version, bringing new things every time and every day. So it's good for you to have a knowledge of it. You can use to model other liquids apart from water. It could be just for you to understand the density and then use the appropriate density and then use the appropriate frictional factor. Whether you're using the Weissbach, you are using Chesney Manning, or you are using Hesse-Williams. Okay, software open, software open. 2 people have opened the software. Others, I don't know whether you're still installing it or you've not installed it. I want to carry everybody along. So it's good that you say, you make a comment, I have yet to do it, or I have done it, so that you don't be left behind. Now, this is the network we're going to draw. I want you to look at this very well. We're going to draw this. It's very simple, it's very easy. But in real sense, in the real world, you might have a network that has up to 1,000 nodes. This one has about eight nodes. But in real life, you might have it up to 1,000 nodes. Then it has about 7 pipes. Okay, 6 pipes and then 1 pump. This is pump 9. So between the reservoir or the water source and node 1 is a pump. And then between 7 and 8, number 8 is a tank. Okay, and then is another pipe. So we're going to be drawing this now. So just take note of it. Okay, let's start. Go to your Epanet now. Go to your Epanet. Let me share again so that to make sure. So go to your Epanet. You go to your toolbar. This is my reservoir. So I'm going to pick my reservoir and I will drop it. Okay. Then I'll pick a node or a junction. I'll pick it, then I'll drop it here. Then when you finish, you go and click this black arrow. This black arrow is like to deselect. It is to select and to deselect. So if you keep clicking, you'll be clicking node, you'll be adding nodes. So what you have to do is if time you are done with any task or any object, you go and click on this select objects so that your mouse will become neutral again. You see, I can click anywhere and I'm free. But before, it was having something like this, a circle, telling you that it's having a command it's running on the command. So for you to deselect it, you just go and click on this thing. Then if I click on something and I don't like it, I want to delete it, I also go and click on this, then click on it, and then right click on it, and then press delete, it will delete. Or I'll go to the black arrow, click on it, click on what I want to delete, and then press delete on my keyboard. It will ask me to confirm if I want to delete it. Good. I will say no for now. Now, if you look at this thing, it's very tiny. I want to show us something very important, how to change this parameter. Before you start drawing, you will need to set your default drawing parameters. And how do you do that? Go to project. Everybody go to project. Click on project menu. And then you go to default. Project default. Project default. Click on project and then go to default. When you go to default, it will tell you, is there any prefix that you want your items to answer? Here you can ask it to answer anything. I can set to say all my junctions should be J. Okay, then all my reservoir should be R, capital R. Okay, how do I get to this place? Go to project, go to, let me cancel it. Go to project, go to defaults. Then you come and click here. Under the ID label tab, there are 3 tabs here. There's ID label tab, there's property tab, there's hydraulic tab. ID lab, property, and then hydraulic tab. So, but I'm on the ID label. So, one of the most important things for you now is that in this ID increment, leave it to be 1. Make sure it's 1. I know by default it's already 1. So that if I'm creating my pipe, it will be pipe 1, pipe 2, pipe 3, pipe 4. It will be increasing by a margin of 1. Then the other thing you do is that go to hydraulics. Here you set how do you want to draw, what flow unit do you want to use. If you click on this GPM under hydraulic tab, still on the default, under project menu, you will see if you click on this GPM, it will open a flyout for you. If you click on this flyout, it will give you other units of measurement: gallon per minute, milligallon per day, MGD, I don't know what it means, AFD, I don't know what it means, LPS is liter per seconds, LPM is liter per minute, MLD is million liter per day, CMH is cubic meter per hour, CMD is cubic meter per day. So you can see, you can choose any unit you want to work with. But for this one is cubic feet per second. Cubic feet per second. This one's gallon per minute. So in American units, they always use gallon. They use empirical units. And this software is an American software. And so the tutorial we are doing now is in American units. So I will crave our indulgence. Let's just do this exercise in gallons per minute. But other exercises we're going to do, it will be in liters per second, just like we did yesterday. So I want you to choose gallon per minute, which is the default anyway. Under the head loss formula, there are many head loss formulas. Those of us that can remember our fluid dynamics. There's Hessing-Williams, there is Darcy Weisbach, and there's Chesney-Manning. So which head formula do you want to use? For now, let us use Hessing-Williams because that's what we know. Hessing-Williams is usually between 100 and 150, depending on the roughness of the pipe. The lower the roughness of the pipe, the higher the Hessing-Williams. For instance, PVC is known to have a Hessing-Williams formula of about between 135 and 150. Then we are talking about water. So the specific gravity of water is 1. The relative viscosity of water is also 1. The maximum number of trials, you can leave it at 40. That's okay. You can take it to 20, but 40 is okay. So by the time the system will do iteration up to 40 times, it will to stop. Accuracy. I can change my accuracy to 0.1 or 1 decimal place. Enter. If you impute any value, please press. You always press enter. Please, if you're not following, chat me up on the chat box. If you're not following, chat me up here. Chat me up on the chat box. If you have issue, please don't be left behind. Okay, now you can set general parameters, but all of them, leave them as they are. It's okay. Then properties. You can set any property here, but for now, no property. Now, this default parameter is telling you, for instance, it's a pipe diameter 12 inches. We're drawn in inches. Remember, you're using American unit, so the pipe is in inches. What this thing means is that if I forgot to impute any pipe diameter, it will assume 12 inches for me. But now I'm going to change my own to 6 inches. Can you change it to 6 inches? And then the pipe roughness, you can change it to between 100 and 150. But let's leave it at 1 to 100. Or let's leave it at 130. So that we know that we're using PVC pipe. All these parameters, all this standard is something that you can Google online. It's there. If you're using German standard, you're using British standards, just open your design manual. It will tell you the parameters. In fact, if you buy pipe in the market, ask anybody that's selling pipe in the market, what is the roughness of this pipe? It will tell you the losses. It's just there. Hello. Hello. Okay, so let's continue. Sorry, it was network. So here you have your junction, you have your everything. So for now, let's leave everything the way it is. But if you want, you can put J. Let's just leave it default. The properties, this length, you can see where you say auto length off. Auto length is off. It means that if I draw any line, it will give it 1,000 feet. If I draw any line, but if I put auto length on, if I draw a segment of a line, based on the scaling that I've imputed there, it will take automatically the same scaling. It will take automatically the same scale. So if I draw a line between here and here, the software will capture it in real time. It will capture it in real time. But for now, let's leave it at off. Let's leave it off. We'll use we'll impute the diameter, this pipeline ourselves. If you know you have the pipe lengths already on the table, then you leave it off. Then later you click each of them and then impute it yourself. So good. So with that, we are good to go. So leave the increment at 1. That's the most important thing. And then click OK. You can save them as default. Click on this small icon here. So to save them as default. And you click OK. Now, I want you to take another junction and drop it here. Now you can see that these things are very tiny, they are very small, and the numbers are not coming out. That number that we want is not coming out. So first of all, I'll go and deselect first. So I'll free my mouse. Then I'm going to show you something very important. You go to view menu, and then go to options. This same thing is in AutoCAD. If you want to change your interface, your color, your mouse, your right click customization in AutoCAD, it's always under options that we do that. If you go to option, you go to preferences. So the same thing applies in this software and in most softwares, I guess. Okay. So now we go to view. If you go to view, you go to options. view, options. It will bring up dialog box like this. Are you there? View menu, option. Please, if there's no noise in your background, you can unmute yourself and talk. But if there's noise or interference, please, you mute it. So far, we're doing well, and I appreciate that. So now, if you go to node, I want you to increase the node size to 5 so that it can be more conspicuous, so you can see it very well. Increase it to 5. Then your links, you can increase it to 2 or 3. Let me increase to 3 so that I can see it very well. Even my node, I can increase to 6. Well, you can leave your own at 6 or 5. Then under label, nothing to change. Under notation, very important. I would like you to display some values for me. Some values. And what are those values? I want you to display 3 values. I want you to display the node ID for me. So I will check the bus for node ID. I want you to display the node value. I will click on it. I want you to display the links. I will click on it. Those 3. Now, if in case you got lost in the course of this training, you quickly refer back to the manual. And in the manual, I think you're already on page. We're already on page 2. We are somewhere here on page 2. So here it says select notation page. So I'll go back. I'll go and select notation page. I'll click on these 3. Symbol. Leave the symbol the way they are. They're already checked. Arrow. You can either choose arrow or you choose field. If you have to choose field, you can increase the arrow size to say 10. Okay. Then background. Some people don't like white background. Some people will prefer a black background. For me, I'll choose the second one. Okay. And when I'm done, remember I changed this to 6. I changed this to 3. I click the first 3. I check the first 3, and then I click OK. You can see the thing is now bigger, and the numbering and the lettering is up. Please, are we all following? Who is not following, please? Okay. I guess everybody's following.
Hello.
Yeah, I can hear you, sir.
Yeah, please. How do you arrive to the 2 and 3, the notes?
Okay, you want to delete it or what?
No. I tried to practice with you, but I noticed that it's becoming too difficult. Let me just watch and see what you are doing, then later I practice. But I've already done the reservoir, trying to do the note 2 and 3. Okay. I got lost.
Okay, follow me.
Yeah.
Now click on node here.
Okay.
And then drop it here.
Okay.
So mine is saying number 4 because it already has number 3. So you cannot give me 2 again. So you drop it. Then for those who are also following, now that I don't need number 4 again, I'll just go and click select.
Yeah.
So select number 4. I click on it.
Okay.
And confirm it. So you can click again. You go back and click the node again. I think you add 1 here. You add 1 here. You add 1 here. And then you add 1 here. Then you go and click the black arrow again. Select objects. So you don't keep adding again. If your numbering, your lettering is not in this form, in order, don't worry about it. It does not mean anything. No 2 engineers can design the same thing and have the same design and have the same positioning of the same design. It's not possible. That means they copied each other. So if peradventure is not the way it's looking, don't worry. Just place them the way it is on these charts, on this exercise. This is the exercise. So this is what I've just drawn. But only the nodes. The next thing, I need to place a tank. If you look at it, you see there's a tank here. Number 8 is a tank. So I'll go to tank. This is tank. Hover around it. This is tank. I'll click on it. The same way you click on node. Click on the tank. Then you come here and you place it. That becomes my tank. Now, if any of the nodes, okay, is not in order, what you just need to do is go and click on this select tool again. Then click on the node. Then hold your mouse down and drag it. I know some of us don't have mouse, but anyhow you know how to hold and drag. Just hold it down and drag. If I want to move this tank now, I can click, I'll go here, I'll click on the tank, it will highlight. I can hold it down and then drag it. The next thing I'm going to be putting the pipes. The next thing I'm going to be putting the pipes. So, the first thing I do, if you look at node 1, the reservoir to node 1, what you have there is a pump and not a pipe. It's a pump. So I'll first of all go and pick a pump. Look at my pump. I'll pick on this pump. Click on the pump. Then come and click on the center of this reservoir. Once you click on it, it will turn to a pencil. The cursor will turn to highlight to a pencil. Then I'll come to the center again of this node 2, and I'll click. Then to add a pump there. If you click and it didn't go off, know that you didn't get it because the pipe is drawn segment by segment. Segment by segment. It will be segment by segment. So I'll go and click a pipe. After I click the pump, it's only one pump I have in my network, so I'm done with pump. So the next thing I'm going to do is I'm going to click on pipe. This is pipe, add pipe. You click on add pipe, it will turn to a cross sign. I'll now come and click on the center here, and then click on the center of number 3. It will add a pipe. Once you add the pipe, it goes off. If it continues to draw, you are wrong. Every pipe segment will come up as a segment. Once you draw it, it will go off. Then I will come here now and click on the center and click on this pipe. It will go off. Either I go and pick it again, I'll continue because it's already on. The later when it will not be on is if I go and click on this black one, it will go off. So I'll click on this one, I'll click on this one, I'll click on this one, 4, I'll click on 6, I'll click on 7, I'll click on 6, 3, 7, 5, 6, 7. So let me give us a few minutes for some of us to draw this network, please. Everybody is expected to draw this network. So a few minutes, draw this network. If you got lost anywhere, chat me on the chat box. Then now that you see, if I click again, I'll start drawing another line. But I have to go and click on this black arrow so that my cursor will be free. Once you click on the black arrow, your cursor is free. So please, can everybody be on the same page? So this is the network. Remember, the network is modified, but in real sense, it can be a 1,000 network. It can be a pipeline made of 1,000 nodes and links and pipe segments. Sorry. So, but this is for tutorial. This is an exercise. This is a simple training. So we'll just use the one that's as simple as possible. So please, any question? So let me say what I said again. What we are going to be doing after drawing our network is to impute 4 parameters into the network, and that's the all. 2 parameters will be on the node. 2 parameters will be on the pipeline, on the pipe. How do you impute values into the network? You impute the value by double-clicking. If I want to double-clicking on each of them, if I double-click on the reservoir, it will give me the head and I impute it. If I double-click the first node, it will give me the elevation and the demand. These 2 is what we'll be changing. These 2.
Your screen.
My screen is gone again.
Yeah. Okay.
So I'll be changing the elevation and the demand for the nodes. Then for the pipe, if I double-click the pipe, I'll be changing the diameter and the length. And the diameter and the length have been given to us on page 4. The diameter and the length. So you, the designer, before you get to computer, you must have used your chart to determine the diameter of each of the pipe, like what we did here on last weekend. Then before you do that, your surveyor must have given you the elevation at every node. And then you must have computed the demand at every node using the neighboring catchments within the node. How many houses or how many areas that node servicing? Okay, you must have used it to do that. So once again, you need 4 parameters: elevation and demand, and then length and diameter. So your job now is in this chart, you will start with the reservoir. Double click on the reservoir, you put your head 700. After that, you double click first of all, do the nodes. You have to do the whole nodes. And these are the node value here. You do these 8 values. If you get to the tank, this is the tank. The tank is 830. The demand in the tank is 0 because the tank does not need water. Rather, it gives out water. So when you get to node 8, you put 830 and you put demand 0. So for each of the demand, each of the nodes, double click each of them and then be putting everything. This one is this. When I come to number 3, number 3 says elevation 710, demand 150. Good. So I'll come here, I'll double click on this number 3. Elevation is 710. Enter. Please press enter. Base demand is 150. Enter. Two parameters. Each time you click any one, those 2 parameters is what you change. So now follow the manual and then impute all the parameters, both for the node and for the pipe. Both for the node and for the pipes. Let me just check. So I'm giving us 10 minutes to do this. Your time starts now. You need 10 minutes to do this. So impute the pipe parameters, impute the node parameters for all of them. Please, if you are done with the pipe, if you are done with the node parameters, you can also change the pipe parameters too, which is the last parameter you have to change. So I will come here. Pipe 1 is, the length is 3,000 feet and the diameter is 14 feet. The one there is my 2 here, so it doesn't mean anything. 3,000 and diameter is 14 inches. 3,000 feet, 14 inches. This 130 is already the one I set by default. The other might be 100. That's still the default. So, and so on and so forth. I will just be clicking and be adding, changing the diameter. This one is number 2, pipe 3. And pipe 3 is this pipe. This is pipe 2. So pipe 2, pipe 1, and pipe 2 are very big because they are the ones delivering water to the tank. So this is 12. This is about 5,000 or so. Then I'll click on this pipe 3 now. Pipe 3 is 8 inches. And the diameter is about 4,000, I think. The length is about 4,000, sorry. And move to the next one. So pipe 5 is 8 inches. Pipe 6 is the only one that is 10 inches. So pipe 6, pipe 8 and pipe 7 are all 6 inches. So this pipe is 6 inches. This pipe is 6 inches. This pipe is 8 inches. Then this other pipe is 8 inches. How about this pipe? I think it's also 8 inches. This one is 10 inches, sorry. So you can click on any of the pipes and check whether it has a length, it has a diameter. Once they all do, then you are good to go. The next thing we'll go to pump sizing. So, gentlemen, now that we have imputed all our parameters, node parameters, 2 parameters for the node, 2 parameters for the pipes, then we have designed the pump curve and the pump is running. We have designed our elevated tank and captured the elevation difference into the design of the curve. Then nothing is stopping our pump from running. If the error message you get is negative pressure, it means there is a small pipe somewhere that is not allowing water to flow. Then, meaning there's a negative pressure, meaning the water is flowing backward. Then if it says that pump is not well sized, then it means that your pump have issue. It means that the pump is not able to deliver that head. So what you need to do is to redesign to check whether the elevation head that you imputed into all your nodes are correct. If they're not correct, it will give you that error. Now, I also said that what we've done now is what we call instantaneous design. It's just like a 1 hour design. And that 1 hour is at 12 a.m. This is the status of the network at 12 a.m. Of which, if you want to view them, you can go to map, click on map browser, and this is extreme right, top extreme right. Under node, you can click on pressure. Under links, you can click on velocity. The system will tell you the velocity and the pressure, and then color code them at every point. And the time will give you single period. So this is single period simulation. And you can find this in our exercise manual on page 5 or page 6 rather. On page 5 to page 6, that's where we are now. So you can practice that on your own later. Now you can also view a head versus the flow. Now you can see the head. You see, due to the pump is delivering a head of about 140 generally. Look at it. Remember, the head is 150, but you cannot see 150. Why? Because 10 has already gone into the system and to make up for friction. But you can see that at the tank, we are having a head of about 840. But what we imputed there was 830. So this is the work of the pump. The pump has lost a head of 10 while pushing water into this network. I can say I don't want to view the head. I can view the demand at the node. These are the demands. How about the base demand? These are the base demand. NA means not available. And then if you don't view the velocity, you can view anything. I know the velocity and the flow that is more important. And then the legend here will give you a legend showing you how it is progressing. And if you want to work on this legend, just right click on it. You change anything. Right click on the legend, you change anything you want to change. Right click on this legend, you change anything you want to change. So now we are going to do what we call we're going to do a long-term running. We're going to do simulation. Sorry, that was the word. We're going to do simulation. We're going to do simulation. Simulation, or we'll do extended period simulation. What we just finished now is what we call a single period or steady state analysis. That means in 1 hour, in a particular time, what is the state of the network? That's what we just did now. But now we're going to do what we call a extended analysis. But before you do the extended analysis, you need to add a time pattern. You need to add a time pattern and a simulation time. So that's the next thing we're going to do. Now, follow me now. Let me show you how to draw a simulation. Okay. Any questions so far? Okay, so here we go. How to run a simulation now. If you want to run this simulation, or let me for the simulation, I think let me any questions so far? Let me end this recording here now. I'll stop the recording.